Now I'm going to explain how to derive this expression, which is x to the power of 2 over x squared. For deriving this expression, we're going to use the quotient rule, which is b times the derivative of u minus u times the derivative of b over b to the power of 2. So this is going to be my u, and this is going to be my b. So I'm going to write down. Be like this. The derivative of x to the power of 2 is 2x minus u. The derivative of x square root, which is this one. All of this over b squared, which is simplified. It's going to be like this, which can also be expressed, and we're going to express it like this for simplicity. 2x like this minus this. We use common denominator, so it's going to be like this. Then over. Now we're going to resolve only this part. So we express the answers with exponentials here, and we use algebra to resolve this equation. 2 times 2, 4, and now we use the rule when we multiply exponents in which we make a sum, and it will leave us with a 2 minus x squared over 2 x square root of x. So now we put this part here, and so we leave us with 3x squared because we simplify this expression times the x we have here. So here we can use we can cross out the x because here is multiplying x squared, and now we have our derivative here is this.
So based on the trigonometric identities, this is equal to 1. The derivative will be equal to 0 because we don't have an x.
So here in the activity 19, they're asking us to find the equation of a tangent line of fx equals to e at the power of 2x minus 1 at x equals 1/2. So first we're gonna find the derivative of u, that is this one. So e at the power of 2x minus 1. So we know that minus 1 doesn't have an x, so we eliminate this equals 0. So we multiply 1 plus 2, 2, and x at the power of 1 minus 1 is 0, so x doesn't exist. So we have that our derivative is 2. So this is the formula to derive the exponential function, that is e at the power of 2x minus 1 multiplying by 2. This is equal to 2e at the power of 2x minus 1. So now we put this in the calculator. So the answer is 2. So now with the old formula, we're gonna find the y. So the answer is 1. So now we're gonna find the equation of the tangent line. So this is equal to y minus 1 equal to 2 x minus 1 million. So we multiply this one, that will be 2x minus 1, and we pass this one, that is plus 1. So we have that y is equal to 2x.
Okay, so now we're going to do the exercise 26, which says find an equation of a tangent line at x minus 1. Okay, so first of all, we're going to apply the logarithmic rules. Okay, that it says that if I have a fraction, this is going to split. So it's going to be like this. After that, it also says that if I have an exponent, it's gonna pass to the front multiplying, in which in this case we do have an exponent, so it's going to be ln 3 ln multiplying to x minus 3 minus ln multiplying for x. The formula says that if I have an ln, it's going to be 1 over my u multiplied by the derivative of my u. So we're gonna do this one first. 3 multiplying 1 over, this is my u, 2x minus 3. And the derivative of my u is going to be 2. Minus, also we're gonna do it again, 1 over 4x, which is my u, multiplied by the derivative of my u. We're gonna start multiplying. 3 times 2 is 6 over 2x minus 3 minus 4 over 4x. We eliminate this, so it goes 1 over x. And this is our new function, in which we're going to introduce the x, which is equal to minus 1, to obtain the slope. And the slope is going to be minus 1.5. We have the x, which is minus 1, but we don't have the y. So in this case, we're going to introduce the x in the original function, and you're gonna grab your calculator and you're gonna introduce the x into this function. It needs to be negative because logarithmics don't inside the parentheses in logarithmics. If you apply, if it is a negative number, it's not gonna exist. So that's why the x is negative. And in this case, the y is gonna be 3.4. After I have my data, I'm gonna find the equation of a tangent line. The formula is y minus y1 equals to the slope I'm gonna substitute all my data into the equation, into the new formula.
Pero fue en primero, pero para el último día de campeón. No.
Okay. I'm gonna leave the y alone.
Fue el último día.
Pero no muy bien porque la última vez que fue era el último día y era comunicación.
¿Son tercera secundaria?
Sí.
O sea que en el último
Yeah, we get it.
And this equals
¿Sabes que nunca,
2 minus x over 2 plus 3.9. So the last exercise is exercise 33. It says to find the equation of a tangent line at x over 0 with this formula. So we're gonna find the derivative of this formula using this. We're gonna first use this one since the base is an x and not an e. And we're gonna find the derivative of the exponent of the x, in which we're gonna use this formula because we have an e as a base. So the new function would be 2e After that, we're gonna substitute a number over 0 in which we're gonna use x as a 1 to find the slope in the new function, which is 0. You're gonna introduce this into the calculator. Is 0, and since we don't have a y, we're gonna do the same. Use the x as 1 in the old formula. The y is 1. After that, we're gonna find the equation of a tangent using this formula. And the equation of a tangent line is going to be 1.